Welcome back to Online Physics with Mr. Peacock. Today we are going over more projectiles. We're on question number 1 in our practice packet. So I'm here on page 6 of the packet. We're working on the mild problem, number 1. So I have the problem drawn here on the board. We have a cliff, over here. We've got a 50-meter tall cliff. We kick a ball directly in the horizontal direction off of the cliff. It falls and lands 40 meters away. And the question wants to know, what was the ball's initial velocity? So what was the initial velocity of the ball? We're going to follow our same steps for projectiles. We know that time connects projectiles, connects the y and the x when we're dealing with projectiles. So we're going to find time in the y direction, and then we're going to use that time to solve for our initial velocity. So let's start with the y direction and list out the things that we know. We know that our starting position, our initial position, is 50 meters because we start at the top of the cliff. We know that our final position is 0 meters because we land at the ground. We know that our initial velocity in the y direction is 0 meters per second because all of this velocity is perfectly horizontal. It's in the x direction. There's nothing going in the y direction, so it's 0. We know that our acceleration in the y direction is negative 10 meters per second squared. Again, technically it's 9.8, but we're going to use 10 to make the math easier. And time is our target. That's what we are trying to find, is time. So we're going to choose an equation that has all of our knowns and our target and has nothing else. And that's going to come out to be our second equation, number 2. So this is our second equation from our equation sheet. And we know we're going to plug in all the things we know that are 0. So our final position is equal to, that's 0. Final position is 0. Initial position plus initial velocity is 0 plus 1/2 a/t squared. And I need to get t by itself, so I'm going to subtract my initial position to the other side equals 1/2 a/t squared. I'm going to multiply by 2 so that I can cancel out my half. Whatever I do to one side, I have to do to the other side. So I have negative 2 initial position equals at squared. Then I have to divide both sides by a. And that gives me negative 2 initial position divided by a equals t squared. And then I have to take the square root of both sides, and I get that the square root of negative 2 times the initial position all over a equals time, and that is my variable answer. And then I'm going to plug in the math, and I'm going to see that the square root of negative 2 times 50 all over negative 10 equals time. And let's see. That's going to give us that. I'm going to bring it back up to the top here. Time equals 3.2 seconds. Time equals 3.2 seconds. So we have found the time in the y direction. Now we need to solve for the initial velocity in the x direction. So in the x direction, we know time is 3.2 seconds because the time is always the same. We know that our starting position is equal to 0. Our final position is equal to 40. The acceleration in the x direction is equal to 0. Because when an object is in free fall, it has an acceleration in the y direction, but no acceleration in the x direction. So that's equal to 0. And we want to find what is our initial velocity. So that is our target. We're going to write the same equation. Final position equals starting position plus initial velocity times time plus 1/2 at squared. And then we're going to plug in all of the zeros that we know. So final position equals 0 plus v naught t plus 0, because we know the acceleration is 0. And we get final position equals v naught t. And then we're trying to get initial velocity, so we have to divide both sides by t. And we get final position divided by time equals initial velocity. And 40 divided by 3.2 equals 12.5 meters per second. So we know that our initial velocity when we are first launched off of the cliff is 12.5 meters per second. So that is how we solve question number 1 in the practice problem. I hope you enjoyed. Feel free to leave comments or questions in the comment section. Be the leaders your community needs and deserves. Choose to be great and make your dreams come true.